Hi, my name is James Campbell. I am the CTO at Superconductive. We're the team behind Great Expectations. And I'm really excited to be talking today about helping to develop a better understanding of your data and automatically creating data quality profiles using a new feature that we've been developing called profilers, and specifically rule-based profilers that really focus on question-driven workflows. I'm going to start off with a little just introduction about myself and our team, and then dive into some of the challenges that we've seen as people get started building data quality tests and dashboards for their team, and then talk about the approach that we're taking in Great Expectations, because it's a little bit different than what we've seen in some of the other places that are also doing really interesting work in data quality right now. And then I'm going to cover how that gets deployed in what we're calling data assistance. A little bit about myself. I was one of the co-founders of the open source data quality project, Great Expectations, together with Abe Gong, who's the CEO at Superconductive. I've spent most of my career working back and forth across different quantitative and qualitative ways of understanding the world. And I think the defining part for me of what's made for interesting problems is that they blend different ways of understanding the world. And one of the things that means is I've gotten to dive in and explore a lot of different kinds of data and get really excited about the patterns that we see in approaches to building up quality metrics. All right. So where do our expectations about data, about the world come from? Often it seems like, and people who are working with Great Expectations sometimes feel like they start off staring at this like blank screen, at this, carrot in the cursor in the sky that is a place for them to begin exploration. And we've really been torn at Great Expectations in terms of how to help people with the balance between being able to draw from their rich domain expertise and also from automated systems. So we've sort of described this process that brings knowledge from a number of different sources. So obviously there's domain knowledge from working with specific data, from working with sensor systems, from regularly buying data from a vendor or getting outputs from a model. And that is the kind of traditional way that we've built expectations and Great Expectations. We've had profilers available for a long time, and I'll talk for a second about some of the challenges they have. But what we're focusing on now is this area of profilers, where we're looking directly at the data and doing everything we can to combine the insights from other places as well in order to create expectations that are particularly meaningful, and also that when they fail later, in the cases of some sort of problem associated with later data deliveries, can provide as much insight into exactly why as possible. So that often means going just a bit deeper than a standard anomaly detection technique. When we think about what kinds of expectations are usually created by a profiling system, there's a lot of big buckets that we naturally go to. And this is true for Great Expectations. It's true for other tools as well. We want to look at things like, what is the schema for this data? Are values routinely updated? How much of it am I getting? Am I missing values? Is the distribution and kind of classic descriptive statistics that we use to understand it consistent? Those are all the things that we want to be able to continue to provide. But we want to be able to do that in a way that really shows where the expectations come from. Because when we take the traditional approaches, what we see is often the alerts that you get are based only on data without any understanding of what you're trying to do with that data. So it's hard to tell the difference between value changing in a way that is a normal fluctuation, or maybe even effectively what you actually expected based on your domain knowledge, and a value changing because of a problem in data delivery or collection. Also, when expectations are created exclusively from data without really anchoring in knowledge about the domain that you're working in, there's a risk of just fatigue from miscalibration. The alerts are classically trying to balance precision and recall, but facing all the problems that any kind of out of the box black box system would face. Also, when you don't have domain knowledge, you're choosing effectively from a smaller library of tests. So that list of expectations that I put up before, those kind of 5 categories, those are great ways to get started, but you'll notice they're all very generic, and they don't get to take advantage of one of the things that's most powerful about the domain-driven approach to understanding data quality, which is that you can have specialists augment the vocabulary that you use to describe a data set. And then, of course, sometimes these automated systems just say dumb things. True story. We one of the first approaches to profiling that was included with Great Expectations, several users were like, "Look, I don't want to know that the mean value of my ID column is increasing." And what can we do? Well, there's kind of a fork in the road. One thing you could absolutely do is say, okay, well, we'll just make the profiler smarter. We can recognize that particular pathology and build into our profiler a fix that will look for particular characteristics in kinds of data that we've seen, and eventually we end up with this bigger and bigger and bigger collection of models. And I just want to be clear, like, this is definitely a good idea, and people are doing it. We should continue to pursue that approach, but it does have some drawbacks. Firstly, when you keep adding rules on top of each other in a single monolithic profiler, or a kind of black box approach to bootstrapping a data quality system, you end up with something that's very difficult to customize and adjust. And for us, where we're trying to really become a shared standard for how people describe data by being able to contribute their own expectations and add packages of domain-specific knowledge and testing, it really undermines that goal. Secondly, when you do have suggestions out of that kind of an approach, it's much more difficult to explain why any particular suggestion was generated. You could sort of backtrack this complicated logic flow, but the specific decisions are a little bit more buried inside the larger model. So another approach would be to decompose those profilers into smaller chunks that individually can explain very precisely what they're doing and be modified. You effectively then end up with a toolkit of relatively modular building blocks that the community can update, add to, and assemble together to create profilers that are both smart, but also individually clearly understandable. The goal, and that's the approach that we're talking about here, is very simple, extensible, composable building blocks, and specifically that are oriented around questions. Now, we get to do the classic appeal here to longstanding knowledge, right? The Socratic method is really the inspiration here. The idea that good questions lead to better understanding. So what we're trying to do is help users who are encountering a new data set and trying to improve their understanding of it and improve their ability to monitor quality changes in that data set, lead them through the process of, or facilitate them in the process of asking questions. So we call that rule-based profilers. Now, again, what we're doing here is creating a framework for assembling other systems. So there are kind of 3 big key components to it. The first is the domain builder, which kind of finds addresses, like think columns of data that we can suggest expectations about. So it's sort of looking at the data to say, well, how can I find a kind of data that I'm interested in? And then parameter builders come in and when they're looking at that data, they say, okay, well, what are the parameters that are going to be most useful for me based on whatever are the historical data and or domain specific knowledge that I have for that. And then finally, configuration builders take the information we have about the domain, about parameters, assemble it together, and create expectations or metrics that really describe the data and help you get insight more quickly as you're working with it. So this collection of a domain builder, some parameter builders, configuration builder, you call that a rule, and multiple rules can be together as well in order to create the profile of a new data set. Okay, so what I want to do now is sort of walk through an example. So let's suppose that I have, from my world of data sources, I have a collection of New York City taxi and limousine commission data. This is one of the classic data sets we use a lot in examples for Great Expectations. It's a data set that has records that correspond one row for each taxi ride in New York City. It includes things like the number of passengers and the total cost. So let's just say for a second that this is landed in a SQL database. And in that database, I've got a bunch of different tables. I've got my trip data for yellow cabs, for example. That's the one that I was just describing. And the first thing I do is I point at that data set and I say, okay, I want to divide this up in some way that is going to be useful for me to be able to get historical data. Now, I don't have to do this to just get started, but by batching up the data in a way that makes sense, I can start to already give some amount of semantic knowledge to the profiler. So I'm saying, well, look, this data, it comes in monthly, or maybe I even want to slice it down to the daily level. And by doing that, I'm giving the kind of knowledge of history. I'm pointing out effectively that this is an event data stream where, the past, once it happens, it doesn't get changed. And there's a continuously updating series of events. Really common kind of data, but of course not the only one. So that leads me to the domain builder portion of a rule. So again, this is all about question-driven discovery. So I start off, because I built batches, I can ask this question of what batches are available. And then I have a variety of different domain builders available to me. So the most basic might just be, say, like, what columns are there in this data, right? Like every time you get a new data set or you're trying to really understand about a data, like the first thing you do is just look at it. Like, what do I have here? You can dive in deeper, though, and another out-of-the-box domain builder that we provide is the semantic types domain builder, which is using rules and they're user defined or user augmented because we ship with some kind of classic or standard ones, but they do things like ask, what are the columns types, right? And it does this using metrics in GE, the same metrics that are going to later be used for evaluating expectations. We say, like, are there numeric columns? Maybe are there numeric columns that aren't IDs? We also might have a domain builder, and we do have a domain builder for looking at categorical columns, like, how many unique values are there in this column? And if that's a small enough number, then we might think that we'd like to put some expectations around the kind of categorical values. Like maybe there's string columns that seem to only have a few different values in them. So again, what we're doing here is we're looking for places in the data or addresses of the data that are going to be insightful for us to take a look at more deeply. And the way we take that deeper look is using parameter builders. So parameter builders will look over historical data and identify specific values that are potentially useful for metrics. So, or for expectations as well. So, the schema parameter builder, it might be just simply taking the names of columns and looking for things like, well, are the names of the columns in the past the same as they are now, or are there changes? Like in that particular data set in the New York City cab data, there have been a lot of changes in column names over time. Some of them are related to exactly the same data, just the columns renamed, and others of them are because there have been other changes in the data collection. And as I'll take a look actually at one of these, the numeric range parameter builder, because I think it's pretty instructive to think about what we can do by looking more deeply into the data and estimating things, but doing it in a kind of very modular, composable way. So I've got this giant word, all the things smashed together in true Great Expectations fashion, which, the numeric metric range multi-batch parameter builder. Wow. Okay. So what is this doing? It's telling us that we can take a numeric metric, like the mean of a column, and we can compute that across a whole bunch of different batches. In this case, I've batched this up by day, and build a parameter by looking at the just purely observationally empirical distribution of values that we've seen. In this case, we're then using a bootstrapping procedure to estimate what we think is a likely valid range for the daily mean of data from the taxi data. So the thing that's noteworthy here is exactly that what we're looking at is a very reusable parameter builder, but one that can also be tweaked. And so we can reuse this same logic across different statistics on different batches or different structures. And critically, we can also replace it whenever it's appropriate for a different expectation. For example, we might know that in certain cases, we want to truncate our values at sign at 0, because it's sort of not meaningful to have negative amounts. Although in the cab data, there's absolutely plenty of negative fares, which I still am trying to figure out. All right, and then we kind of get to this like Lego factory where the configuration builder really assembles together all of the insights from the domain and parameter builders, and potentially uses conditions and other kinds of business logic in order to propose expectations that are valuable for identifying when things are changing, or metrics that are useful for descriptive analysis. Okay, so let's suppose now that I have all these components, and what can I do? At this point, I have the ability to really start asking questions at a higher level than I did before. And we call that a data assistant. So for the example, the statistics assistant is really just saying, like, what are the descriptive statistics that describe this data? Now, again, that's a question that you repeat over and over. It's a classic part of the discovery process, the exploratory data analysis process for working with a new data set. Similarly, for missingness, like, we're going to start asking questions like, which columns have missing values? How frequently? What's normal for these columns and for the frequency of missingness? In every case, these assistants are composed out of the building blocks that can really contain the domain knowledge that we have, as well as the knowledge that we've inferred from building our or from evaluating historical data. And that makes it easy for us to get started and build an understanding of the data much, much more quickly. Let's take a look just really quickly at like how that is happening. I'll just dive into a couple of those. So, for example, in the Schema Assistant, we really are just following a very, very simple flowchart. What columns are present in the data? All right. In this case, the schema is just saying, like, what's there? What are their types? And okay, let's expect the same schema in the future. I mentioned this already, but the vendor name disappeared and the vendor ID column appeared in the most recent batch. That becomes a very natural thing that we can say on the basis of this Schema Assistant. And one of the things that really is a hallmark of great expectations is that for our expectations and metrics, we focus on making sure that they can be quickly translated and easily translated between questions, between statements, between descriptive and diagnostic forms. So being able to kind of construct this sentence out of the observation becomes very natural because we're using the same underlying metrics for the expectations as we did for our profiling. Same thing. If we look at a data distribution assistant, maybe a little bit more complicated of a flowchart, but very similar, right? We're in this case looking at, let's like dial in on a couple of different kinds of data. So using a couple of different domain builders. If I look at numerical columns, then I can throw a couple different parameter builders at it. I could say, well, we talked about this, the non-parametric approach, but I could also ask for, what are there, standard parametric distributions that I potentially want to apply to this data? And I can use that to then create expectations. And again, in all these cases, the expectations that result will flow back through each of these composable building blocks. And what we want to be able to see is that the community of partners in the broader data quality project build their domain knowledge into these components and share the individual components and then the broader assistance in a framework that really helps people to get going quickly with their data quality project. All right. That's a lot. Thank you so much. It is an absolute pleasure to get to talk to you all and overview the Great Expectations profiling feature. We've been putting a lot of work into this, and obviously one of the things that is most defining about it is that there's a real opportunity for the community to participate and to create new things together. We really feel like what we've built here is largely a platform. You notice I called it the Insight Engine at one point. And it's a platform that we hope people will be able to build on effectively in order to get their process of building data quality systems underway. Thank you very much.